Hello everyone, welcome back to our low temperature thermochronology online lectures. We'll be continually learning Chapter 5, Fission Track Thermochronology, Theory Background. Today, we'll be learning the last section of this chapter, that is, Presentation and Modeling of Fission Track Data. As is showing in the two plots here, fission track age data are often reported in the form of a radial plot. It is a characteristic plot used for fission track age data presentation. Individual confined track length data can be measured to a precision of 0.2 microns, and typically 50 to 150 individual track length measurements are made for one sample. The fission track length data are usually reported by a representative length distribution, generally a histogram. And all the above data, including age and track length data, can be shown in tables as well. Here is a table, for example, showing fission track age and length data. By modeling of appetite fission track parameters through likely thermal history scenarios, we can define the range of temperature time conditions, giving predictions which are constant with the observed data. Common detrital appetite grains in sedimentary rocks from around the world show significant variations in chlorine content, both within individual samples and between different samples. The kinetic model used to extract time temperature solutions from appetite fission track data takes into account the effect of chlorine content on annealing rates. Calibration of this kinetic model against the data from simple geological situations confirms the validity of the model. Using of a kinetic model that does not take compositional effects into account, for example, the figure on the bottom right provides a very poor match of the calibration data. When we are trying to do time temperature modeling of thermal histories, there are two ways of modeling we can try. First is forward modeling, and the other is inverse modeling. In the case of the forward modeling, it is the user trying to find a time temperature path that can reproduce our mirror data. It is often a trial and error process. We input the parameters and see if the predicted time temperature path can reproduce our input data. Whereas for the inverse modeling, it is different from the forward modeling. In the inverse modeling, we will let the computers find all possible time temperature paths of our input parameters. In this kind of modeling, all we need to do is input our mirror data and set a few constraints on the time temperature history and let the program run automatically. The above is all for section 5 of this chapter. Thank you very much.